All right, guys. So we are going to be doing a solubility lab in person. You guys virtually here, we're going to kind of have to just do the main outcome from the lab, which is actually just to write net ionic equations. Okay. So if we remember, right, we said that we can form a precipitate, right? We can do a precipitation reaction when we do a double replacement reaction. So our generic form for our double replacement reaction is AX plus BY goes to AY plus BX, okay? So in the lab, we're going to do a number of double replacement reactions. You guys are going to have to just write the net ionic equations for them, okay? So if we think about this right here, we're going to combine ferric nitrate and sodium sulfide, right? Both of these are water-soluble solutions. So if we look, right, nitrate, if we go look in our note packet at the table, nitrate is always going to be soluble, and sodium as a group 1 ion is always going to be soluble as well, okay? So these two solutions are soluble, okay? So what we are going to do, right, we're going to combine those two solutions. So if we think about ferric nitrate, right, that would be FeNO3 3. This is going to be in solution. So if we think about it in solution, right, that would be Fe3 plus aqueous and NO3 minus aqueous. Now, of course, we're going to form 3 of them to make that balanced. Okay, so we have Fe3 plus in our solution, and we're going to have NO3 minus in our solution. Okay, we also, right, sodium sulfide, sodium would be Na2S. So we have sodium, which is a +1. Sulfide would be a S minus 2. Our sodium sulfide is going to be Na2S. In solution, right, it is going to be totally soluble. So we're going to have Na plus, which is aqueous, and S2 minus, which is going to be aqueous. Okay? So these two solutions, right, we've got all of these ions in there. These are our two starting solutions, okay? So our two starting solutions are totally soluble. We can write out what each of our ions are, okay? We're going to have our overall equation, right? Our overall equation we would be able to write a balanced chemical reaction with, okay? Then, once we have that balanced chemical reaction, we can decide which product is the precipitate, right? We can go look over at our Fe2S3 and our NaNO3 and look and decide which one is a precipitate, right? The other piece that we could do is we could take and ignore this piece. We're just going to ignore all of this, right? We're going to take our ions and we're going to write them as our starting reactants, okay? So these are all of our ions here, right? This is writing our ionic equation. We're going to take those ions, and we know that, hey, iron started with nitrate. Well, let's compare if iron combines with sulfur, all right? Iron 3, S2 minus, right? If we combine those two, we know that we're actually going to form Fe2S3 as a solid, because if we look, sulfide is going to be insoluble, okay? So if we go look at our table, we're going to decide that Fe2S3, which would be our uncharged compound from iron 3 plus and sulfur 2 minus, we combine those two ions, we're going to form Fe2S3, which is an insoluble product. If it is insoluble, we can write it as a solid, okay? Then we can combine our other two ions, right? Na plus and NO3. Well, both of those are soluble, so in the ionic equation, they are going to stay as aqueous ions. Okay, so when we look at this, then we realize that sodium and nitrate are called spectator ions because they are unchanged on either side of the equation. Right? We have Na1 plus, Na1 plus as a reactant and as a product. We have nitrate as a reactant and as a product. They are unchanged. So that means that they are a spectator ion. Okay? So our overall net ionic equation is we're going to remove those spectator ions. So we can take this spectator ion out, we can take this spectator ion out, and we're going to only write what is left. So we have 2Fe3 plus, we have 3S2 minus, and we have Fe2S3 as our only product there. Okay? So what we want to do is we can take, we're gonna take not quite exactly this, but we're gonna write take 5 of our solutions on the top up here within the lab. We're gonna take 3 of these on the left. Okay, we're gonna take 5 across the top, 3 on the left. You guys can choose. I want you to write a few reactions, okay? So 5 on top, 3 on the left. First off, we're going to write the dissolving equations. Okay, so the dissolving equations are just like these up here. Okay, so on our lab sheet, right, we've got something like Al2NO3, 3. This is a soluble, ionic compound. So in solution, when it is in water, it is going to be separated. So we want to write it as that separated piece. Okay, just like we did with our iron nitrate. Okay, so we want to write first off the dissolving equations. Okay, so 5 on the top, 3 on the left, just like we did up here. Okay, our second piece, we are going to write the full ionic equations. Okay, so again, 5 on the top, 3 on the left, we're going to have those combinations. Okay, so maybe we have aluminum nitrate here and sodium carbonate. We're going to write the full ionic equation for this combination. Okay, just like we did up here, where we have taken each of our ions. We take each of those ions and we're going to combine them, right, to form our AY plus BX. We're going to decide, are they going to form a solid, or are we just going to have an aqueous ions left with them? Okay, so once we write that full ionic equation, that then should decide if we can write the net ionic. If we go through our full ionic equation and we formed a solid precipitate, then we can remove our spectator ions and we can write the net ionic equation. Okay? So this is our goal for the lab. All right? This is what I want our online students to do. Okay? Thank you very much.